quantum advances that could make human teleportation a reality. Scientists want to teleport an entire human being. A quantum breakthrough could make it a reality. There is just one detail. Every atom in your body would be completely dismantled down to the quantum level, effectively leaving your original body completely destroyed. Scientists first demonstrated that teleportation was possible in 1993, when a team at IBM published a paper in the journal Physical Review Letters on teleporting a quantum state, rather than just an object. 5 years later, physicists at the California Institute of Technology and the University of Wales in the United Kingdom put the theory into practice by teleporting a photon, the particle that carries light, through a meter of coaxial cable, a type of transmission line commonly used to connect satellite signals or broadband internet. Like flying cars and time travel, the ability to instantly move something through physical space is extremely appealing, even if it seems impossible. However, scientists are convinced that a breakthrough in quantum computing technology could make teleportation a reality. Until now, the most advanced teleportation experiments have relied on photons. But as recently as 2020, scientists discovered that it may be possible to teleport electrons, which can maintain their quantum states for longer periods. So, is transporting more complex matter the next step? If we can move particles of light and electrons from point A to point B instantaneously, could we teleport entire atoms, molecules, living cells, and eventually some brave human volunteer? And perhaps more importantly, even if we found a way to teleport entire humans, should we? After all, there is no guarantee that all the particles in your body, once reassembled at their destination, will form a completely intact and fundamentally unchanged you. Quantum computing is based on the peculiar science of quantum entanglement, which has no relation to our everyday experience of Newtonian mechanics, such as masses, forces, and their related effects. Entanglement belongs to the realm of quantum mechanics, where matter and energy at the subatomic scale behave in bizarre ways. The state of physical properties between entangled particles, such as position, momentum, spin, or polarization, is transferred from one particle to another, seemingly by magic, regardless of the distance between them. This almost ghostly natural principle has a very exciting real-world application in quantum computing. While current computers are based on electronic bits that have one of two states, 1 or 0, quantum computing works with qubits, or quantum bits, that can exist in two states simultaneously. This is called coherent superposition. A qubit can perform two calculations at the same time, simply because it exists in both superposition states. By connecting these qubits using quantum entanglement, the computing power increases exponentially. Today's quantum computers can handle massive loads much faster. For example, a 2019 study by Google showed that a specific calculation could be performed by a quantum circuit in about 200 seconds, whereas it would take 10,000 years on the fastest supercomputer in existence. This makes quantum computing the only practical line of research into entanglement so far, and, by extension, a tool for advancing the engineering of teleportation. Among the many advances in teleportation technology since the 1990s, scientists at the University of Innsbruck in Austria and the National Institute of Standards and Technology in the United States teleported particles using quantum entanglement in 2002. It was the first time that teleportation had been accomplished without any direct connection between the original particle and the final one. In 2016, physicists at the University of Calgary in Canada teleported a particle 6 kilometers, or just under 4 miles, via the city's fiber optic cables. A year later, scientists in China teleported a photon from Earth to an orbiting satellite more than 300 kilometers up. Perhaps the most critical milestone came in 2012, when researchers from the University of Vienna in Austria and the Austrian Academy of Sciences teleported photons between two landmasses in Spain's Canary Islands, through open air. Instead of transporting particles via cable or other fixed medium, the team eliminated the need for carrier technology. This feat more closely resembles the way we imagine teleportation in science fiction. Optical setup that generates entangled photons for public demonstrations and education. A blue laser beam passes through a crystal that converts a blue photon into two entangled infrared photons, simulated in the photo by visible red laser lines. A similar, though much more complex, setup was used in 2012 at the Jacobus Kapteyn telescope on La Palma to generate pairs of entangled photons in the teleportation experiment. Credit IQOQI Vienna, Austrian Academy of Sciences. However, scientists may be able to base the science of teleportation on a mysterious force that keeps the physical states of distant particles in sync. This would allow two photons to form a single quantum state, even though they are widely separated, explains cosmologist and theoretical physicist Paul Davies, PhD, director of the Beyond Center for Fundamental Concepts in Science at Arizona State University. This means that the results of measurements performed independently on each photon are correlated in a way that is impossible for classical pairs of objects, such as left and right-handed gloves, he explains. Imagine three particles, A, B, and C. Suppose B and C are entangled, and particle A has a physical property, such as motion or energy, that you want to teleport to particle C. First, you entangle A with B, and then measure both. Then you send the measurement to C, and find that the property established in particle A now applies to particle C. This has occurred without A and C ever touching or directly affecting each other. In other words, A has been teleported to C, indicating a transfer of quantum states between particles. Einstein famously called such effects spooky action at a distance. So far, scientists have not determined the ideal mechanism for transmitting a quantum state. So far, researchers have used coaxial cables, fiber optic cables, and even experimented with no transfer medium at all, as in the 2012 experiment in the Canary Islands. Would a pulse of light or perhaps radio waves be the best option? Would teleportation only work in the vacuum of space? Researchers believe the secret to communication between entangled particles may lie in the wave function between them. Such particles have phases, just like a wave in the ocean, with amplitude, wavelength, and frequency. An even stranger effect of entangled quantum information that scientists need to overcome is that when the quantum state is applied to an entangled particle, the original particle's quantum state is spontaneously destroyed. Davies explains that the effect is to irreversibly collapse the wave function into a specific outcome from a set of probabilities. There are many answers for how to solve this problem, but no consensus, he adds. Could this mean that the original copy of what was transported is actually destroyed? This question is still open and makes teleporting humans an issue fraught with ethical dilemmas. Currently, that holy grail of teleportation, transporting entire human beings from one place to another, is not yet possible. The human body is made up of about 10 to the power of 27 atoms. Each atom is made up of electrons, protons, and neutrons. Each of these subatomic particles is made up of smaller parts, such as quarks or muons, and they all have their own quantum states. Imagine the colossal number of quantum states we would need to calculate in order to send your entire physical being to point B and reassemble it exactly as it was at point A. Before we understood what quantum mechanics could do, most science fiction writers of the atomic age assumed that matter would be disintegrated, transported somewhere, and reconstituted. But quantum entanglement has shown us that we're not literally transporting matter itself. We're transporting information about what makes up a quantum state, Davies explains. And, as many scientists, including Davies, argue, it is information, not matter, that should define life. The atoms inside you are the same as those in a rock or a rubber ball. The only difference is in the number and arrangement of the particles, which determines how they interact chemically. If we ever overcome the computing power hurdle, something that a leap in quantum computing technology could make possible, could teleporting a person be as simple as taking a quantum scan of their body and sending it as an email attachment? The uncertainty principle prevents us from knowing both the velocity and position of a particle simultaneously. So no matter how carefully you scan the quantum state of every particle in your body, you'll never achieve 100% fidelity. What could these signal errors mean for quantum copying? Perhaps your teleported self will arrive unscathed, only to discover the next time you sit down to dinner that you now love broccoli, even though you used to hate it. Or the loss of fidelity in your teleported self could be more severe, so severe that it could become catastrophic during the reconstruction of your body. Even if we manage to overcome all these challenges, we must consider a philosophical question. Do the atoms in your body and all their quantum states constitute the being that you consider to be, well, you? Experimental and theoretical physicist John Clauser, who, along with his colleagues, won the 2022 Nobel Prize in Physics for their work on quantum entanglement, has a take on this question that might give you pause. Imagine you are told that if you step into this box, every atom in your body will be disassembled, effectively leaving your body totally destroyed, killing you, says Clauser. In addition, you are also told that afterward, a replicant of you starts walking around, taking over your life as you know it. Would you step into this box? I certainly wouldn't. Quantum advances that could make human teleportation a reality. Scientists want to teleport an entire human being. A quantum breakthrough could make it a reality.